So right here on this class opener, we have a standard form quadratic trinomial. And if it were in vertex form, it's really easy to find the vertex. All you need is a h and k, right? Think opposite on h, take k for what it is. But right here, we don't have an h and k. It's in standard form. What we have is ax squared plus bx plus c, where your a is negative 6, your b is negative 24, and your c is negative 25. So we need to find the vertex. They're asking us to find the vertex. That's the most important point of any parabola, the vertex. And of course, to find that vertex, we need what? Anybody? How do you find the vertex? You can't see it, right? It's not negative 24, negative 25. It's x equals negative b over 2 times a, right? We should all know that. Everybody write that down. That's the formula for the x value of the vertex, okay? Now, how do we use this formula? Like any other formula, when you plug in values, I recommend plugging them in with parentheses. So we know that the b value is negative 24. Put a negative 24 up here. We know that the a value is negative 6, a negative 6 down there. So what do we have left? We have a positive 24 because a minus negative changes to plus plus because a negative times a negative is a positive. And on the bottom, we have a negative 12. So we know that the vertex x value is negative 2. Are you with me? All righty. So yes, the x value equals negative 2. We use the formula for that. Negative 2 is the x value of the vertex. We still need to find the y value. On any equation with x's and y's, whenever you have the x value and you want the y value, all you do is plug it in and solve. So what I'm going to do is rewrite this identical equation, but instead of x's, I'm going to put parentheses. There it is. And I put those parentheses because I already know that my x value is negative 2. I'm going to simply plug that in. And now it's time to do some math. Of course, we're going to use the correct order of operations. There are no parentheses. I mean, there are parentheses, but there's just a number in there. We move on to e exponents. We have a negative 2 squared. Negative 2 times itself is positive 4. And of course, you still have the negative 6 right in front of it. So negative 6 times positive 4, let me write it over here since I'm running out of space. That's negative 24. And then over here, I have a negative 24 times negative 2. And that'll give us a positive 48. Just wrote it down there. And of course, over here, we have that minus 25. I'm just going to rewrite it. So now I just have a bunch of addition and subtraction. I'm going to go from left to right. Negative 24 plus 48. That'll give me a positive 24. And 24 minus 25, that will give me the answer negative 1. Now, what did I just find? I just found the y value. Y equals negative 1. And of course, we are talking about the y value of our vertex, which is negative 1. So if they ask you to find the vertex on a standard form quadratic equation like this one, you have to do all that work using the vertex formula. But after that, all the other details come very, very easily, right? Because the axis of symmetry equation, this guy is simply x equals what? The x value of the vertex, negative 2, right? And you have to put the x equals because that's the only way to get a vertical line. What else? Is this a maximum value or does this parabola have a maximum value or a minimum value? Okay, now if you guys are confused, if you're confused, yeah, if you throw something up in the air, it reaches a certain height, a max height, and then it comes back down. That is the form of a parabola, right? Throw something up in the air, it's going to reach a maximum height, then it's going to come back down. That's a parabola. Opening down. So if it's opening down, then you do have a max height, and we know that it's opening down because it's negative. So we definitely have a max height. So it's definitely maximum, right? Where is the max at? The max is at what? What is the highest point? Like, so if I have a parabola, what's the highest, this highest point right there? That's the vertex, right? So you could say that the max is the vertex itself, or you could say the max is at negative 1, because when you are talking about height, right, up here or down there, you're talking about differences in the y value. So you could just say max is at negative 1. That's the y value of the vertex. You could say the max is at the coordinate, the vertex coordinate, or you could say the max is at the y value of negative 1, right? Any one of those is perfectly acceptable, right? The X-Intercepts, that one's interesting. You see, to find the Y-intercept, you set x equal to 0 and solve. To find the X-intercepts, you set the y equal to 0 and solve. Now, there are no y's right here, but technically this g of x is a y, right? So if I were to set this equal to 0, what I would have is a quadratic trinomial equation set equal to 0, which we haven't done yet, which we're going to wait till later to do. And you solve those using the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. You guys remember that from Algebra 1? Probably, probably not. Anyways, we're not even dealing with that right now. Right now, we could just understand what the parabola looks like, understand the vertex, understand how it opens, and we'll be able to conclude what the x-intercepts are. So just to do a quick sketch right here of this g of x function, where's the vertex at? It's at -2, -1. So it is right here, okay? Does this open up or down? Opens down because it's negative. And then what about this 6? The a value of 6, what does that cause the parabola to do? It gets narrower. It's called a vertical stretch. It makes it narrower. So we know that this thing opens down. We know that it's pretty narrow. Okay, it's pretty narrow. So I'm asking, what are the x-intercepts? Where will it cross the x-axis? It doesn't. It won't. So what are the x-intercepts? We put none. They don't exist. It does not cross. Whatever you want. But the bottom line is this parabola will never cross this x-axis. It'll never reach it. It'll never touch it. It'll never cross it. Now, if this would have been a positive 6 at that vertex, yeah, then it would cross 2 times. Right? Then we could worry about where it would cross. But anyway, those are the x-intercepts. That was concluded by thinking of the sketch. What about the y-intercepts? What's the y-intercept? Like, I can't see, even with the sketch, I don't know, it's going to cross somewhere down here, the y-axis, because it's pretty narrow. It's going to cross somewhere down here, but I don't know what that value is. Algebraically, it's really easy to find out. What's my y-intercept? -25. That's exactly right. The y-intercept is -25. You could also say is the location 0, -25. That's the coordinate, right? Any one of those is totally fine. You can say y-intercept is -25. You could give the coordinate. Either one of those is fine. What that means is that this parabola will cross way down here somewhere at -25, the y-axis. Now, it's important to, I guess, mention that the y-intercept, it's ridiculously easy when you have it in standard form. But if you have it in vertex form, like let's say you had y equals -6 parentheses x minus 2 squared plus 5, your y-intercept will not be 5, right? It won't. It's only when you have it in standard form where your last number will be your y-intercept. How do we find the y-intercept anyway? Algebraically, you have to set x equal to 0 and solve. That's why when you put zeros right here on these x's, everything cancels out and the c value is your answer, -25. But over here, if you set x equal to 0, you'd have 0 minus 2, that's -2. -2 squared is +4. -6 times +4, -24, plus 5, that'd be -19. Your y-intercept here would be -19. A lot more math to do, right? So I want to make this clear. When it's in standard form, your y-intercept is a c value. When it's in vertex form, you actually have to plug in 0 for x to find your y-intercept. I hope everybody's following along, and I hope that makes sense to everybody. Anyway, domain and range. Well, the domain of any parabola is x equals all real numbers. Doesn't matter if it's wide, if it's narrow, if it's opening up, if it's opening down. The domain is x equals all real numbers. Now the range, it's y is going to be either greater than or equal to a certain minimum value or less than or equal to a certain maximum value. Now we've already mentioned that the maximum value is at -1. So maximum value at -1, so what's our range going to be? Less than or equal to that -1. Okay, that makes total sense. This narrow parabola from left to right is going up, 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 reaches a maximum height of -1 on the y, and then it goes back down -2, -3, all the way to negative forever, right? So I hope this makes sense. Now for the final detail here, the last thing on the class opener that they asked for is for you to state your transformations, describe the transformations from the original to this new graph right here that we have. Okay, so what I would like to do is visually show you the different changes that happen. All right, so this negative sign, that negative sign, your original parabola starts here, the parent graph. That negative sign, what is it? What's the first thing that changes? It reflects over the x-axis. So everybody should write that down for the first thing. It reflects over the x-axis because you have a negative sign right there. If that would have been a positive 6, it wouldn't reflect, right? Okay, so step 1, transformation number 1 is that it reflects over the x-axis. So you got a regular looking U-shaped curve opening down with the vertex at 0, 0. Now, the number 6, what does that do to this parabola? A vertical stretch. So it makes it narrow, right? A vertical stretch by a factor of 6. So everybody should write that down, a vertical stretch by a factor of 6. And then from there, I need a shift according to h and k. But the problem is, there is no h and k right here. So, because it's not in vertex form. But we know the vertex, right? What's the vertex? -2, -1. So again, transformation number 1, it gets reflected over the x-axis. Transformation number 2, it gets vertically stretched by a factor of 6. And then your vertex tells you that you'd have to shift the final transformation, shift 2 units to the left and 1 unit down. So that's all that's the description of the entire transformations from the original parent graph. Gets reflected over the x-axis, vertically stretched by 6, shifts 2 units to the left and 1 unit down. Okay? All right. Cool. Wow. So there are the transformations that you guys should have written down. Anyway, let's move on to the actual lesson today. We should be very comfortable with these 2 forms. What form would you prefer if I told you to graph a parabola? Vertex form or standard form? Vertex form. Way better. Why? Because if it's in vertex form, if it's organized like this, you could see the h and the k, and that's your vertex. You don't have to do any math. And if your a value is 1 from that vertex, use a pattern 1, 1, 2, 4, 3, 9. Everything's really easy if it's in vertex form. Oh, wait a minute. By the way, they should have a y equals right here in front. My bad. So we love vertex form. But what would you rather have, vertex form or standard form, if I asked you for the y-intercept of a certain parabola? Would you rather have vertex form or standard form? Standard, absolutely, because to find the y-intercept, you set x equal to 0, which means that these 2 x's become 0, and your answer is the c value. That'd be your y-intercept value. So each form does have its certain advantages. Most of the time, vertex is the best, right? So on this section, we want to be able to take a standard form equation and make it look like vertex form, okay? So there's many, many ways of doing this. There's many methods that I've taught in the past, but we are trying to catch up to the other classes, so I'm just going to teach you the direct, quickest way, right? To write a vertex form equation, when they give you a standard form equation, in reality, all you need is 3 things: the a value, the h value, and the k value, right? If you have those 3 things, if you have the a, the h, and the k, you'll be able to write it in vertex form. If I do give you a standard form equation, will you be able to identify the a value? Yeah, it's going to be the same a value as that. Will you be able to identify an h and a k? Well, not immediately, but with the standard form equation, you could be able to find the vertex using the vertex formula, and we should all know by now that the vertex is the hk value. Yes? Okay? So you could easily take this standard form quadratic trinomial equation and rewrite it in vertex form, just knowing that if I could just state my a value, my h value, and my k value, I'll be able to write my equation in vertex form, y equals a parentheses x minus h close parentheses squared plus k. So what is my a value? It's the same a value as this one, it's 1. And then over here we have a b and a c. So I know my a value is 1. Now I am going to find h and k. How? By finding my vertex, because my vertex is my hk value. And how would I find a vertex to a standard form quadratic equation? I would have to use a formula. x equals negative b over 2 times a. And of course, when you use a formula, or whenever you plug in values, I recommend plugging them in with parentheses. So we could clearly see that the b value is 10 and the a value is 1. So what we end up with is negative 10 over 2, which is negative 5. So what did I just find here? I found what? The vertex x value, which is negative 5. Okay? So I still need the y value. How am I going to do that? Plug it in. That's right. Any equation, when you have your x's and you want your y's, all you do is rewrite it, plug it in. So I'm going to rewrite the above quadratic equation, y equals x squared plus 10x plus 20. Notice that instead of x's, I put parentheses because I already know my x value. My x value equals negative 5. I found that with the formula. So all I need to do is plug in that negative 5 right here and right there, and I'm good to go, and that's what I'm going to do. Plugging in negative 5 right there, negative 5 over here. Let's do some math. Negative 5 squared, that's negative 5 times negative 5, that's positive 25. Positive 10 times negative 5, that's negative 50. And bring down the plus 20. From left to right, when I go 25, take away 50, that'll give me a negative 25. And negative 25 plus 20, that is negative 5. Are you with me? So the vertex y value is negative 5 as well. So now that we know the vertex x and y values, we technically know our h and k values. Remember, the vertex is hk. So our h is negative 5, our k is negative 5. And now we could easily write it in vertex form, y equals a parenthesis x minus h squared plus k. And again, this is vertex form. So let's take those a, h, and k values and plug them in. Here we go. Y equals, the a value is 1. Open up some parentheses, x minus, the h value is negative 5, close parentheses squared, plus another k value, which is also negative 5. That's your vertex form equation, but let's clean it up. Let's make it as nice as possible. The minus minus, change the plus plus. The 1 out here in the front, it's not even necessary. You don't even need to put the 1 out there in the front. And this plus negative 5, you could just put minus 5, right? So let's clean it up like that. And here it is, our answer, y equals x plus 5 squared minus 5. Ladies and gentlemen, this is vertex form right here especially. So we have changed it from standard form up here to vertex form down here. And like I said, I will teach you other methods in the future, but right now I want to advance in the sections that we're on in the chapter. So we're just going to leave it at that. If you could identify your a, which is going to be the same a value as your standard form equation, and you could find your vertex, you technically have your a, your h, and your k. Just plug it in and it'll be in vertex form. Yay? Okay, now how about backwards? Could you take this vertex form equation and, you know what, do me a favor, even though it's not in the instructions in your paper right there, go ahead and say change back to standard form. Change back to standard form. Well, we know standard form is ax squared plus bx plus c. There are no parentheses, right? And right here we have parentheses. So we don't want those parentheses. So in order to get rid of parentheses, we're going to do the math. What math? We're talking about the binomial x plus 5 squared. So when you square something, you really multiply it with itself. And let's not forget about the minus 5 that's at the very end. So if you passed Algebra 1, you should be able to distribute and combine like terms. And that's really what your standard form equation will be. Let me show you. Let's distribute x times x, x squared. X times 5, positive 5x. How about positive 5 times x? That's another positive 5x. Positive 5 times positive 5 is positive 25. Let's not forget about this minus 5 at the very end. Bring it down. So we have distributed. Now all we need to do is combine like terms. So let's combine the middle terms. This 5x and that 5x will be a positive 10x. Bring down the x squared in front. Of course, bring down the y. Y equals that x squared plus 10x. And over here, 25, take away 5, that's plus 20. And guess what? We have converted it back to standard form. I mean, if we go back to the original, that's what we started with. Y equals x squared plus 10x equals 20. That's what we got down here. Y equals x squared plus 10x plus 20. Did I say equals 20? Sorry, plus 20. Same exact quadratic trinomial equation. Up here and down there. So you're probably thinking, well, why do I want to change it back if I started with this? Let's say, I'm telling you on the practice quiz, which is already available, by the way, on the practice quiz, I give you a parabola. You'll be able to clearly see the vertex. So you'll be able to clearly state the h and k. And you'll be able to look at the parabola. And if the pattern's 1, 1, 2, 4, 3, 9, you know your a value is 1. So you will be able to have your a, your h, and your k. And it'll say, select which of the following quadratics represents this graph. And on the practice quiz, there's more than one equation. One of them is in standard form and the other one's in vertex form. So if you write it in vertex form, you'll have the equation that you should select. But then you're going to have some other standard form equations. And you could go through each of those standard forms and find the vertex and see if it gives you the same vertex. But that's kind of a waste of time. Whenever you have this vertex form, the easiest thing to do is to change it to standard by writing the binomial twice, distributing, combining like terms, and then you're back to standard form. You could easily find which equation is represented on the graph. Does that make sense? I hope so. I don't know. Let's try another. 2, 3, or 4. Which one? Pick one. 4? 4. Okay, so let's say you wanted to change this standard form to a vertex form. Well, first of all, you need to know what you're looking at. What is your a value? Your a value is 2, right? X squared. The x squared is just x squared. And what's your b value? 0. There is no x term. There is no bx term. And then the c value is 2. Does that make sense? So if you wanted to do it exactly the way we just did it, you'd have to say, oh, a is 2, b is 0, because there is no bx term right here in the middle. And the c value is the number by itself at the end. That's 2. And then you could use a vertex formula, plug in your b, negative b over 2a, get the answer, plug it back into the function, get the y value of your vertex, and then continue that way. But this is something that we should all recognize. There is no bx term. And when there is no bx term, it's ridiculously easy to make it look like this. Wait a minute, I always put h and k in red, sorry. You see, this is what we want it to look like, and this is what it actually looks like. When there is no bx term, you could easily put parentheses around the x and have the square on the outside. So you could easily put parentheses around the x, have the square on the outside, and boom, you're done. Now, what do I mean by boom, you're done? What is the h value that's being subtracted in here? 0. What's the k value? 2. What's the a value? 2. Done. Right? I mean, if you wanted to make it look nicer, you could write it like this. Y equals 2 parentheses x minus h squared plus k. But that's the easiest way of doing it. The other way would be to do what we did over here. And then, okay, go x equals negative b over 2a. Use parentheses. I'm not going to do that, right? You're going to end up with the vertex being 0, 2 anyway. Okay, so this is the easiest way of doing it. When you have just an x squared term, when there is no bx term, you can put parentheses around that x, and boom, it's already done in vertex form. Let me ask you this. Does this get reflected over the x-axis? No. Is there a vertical stretch or compression? Vertical stretch. Let me ask you this. Where will the parabola, or will it cross the x-axis? Does it cross once, twice, or it doesn't cross at all? does a parabola cross the x-axis? If you're thinking, well, I don't know, I'm not looking at the parabola. Do you know the vertex? Where's the vertex at? 0, 2, isn't that up here? Right? Is this opening up or down? How many times does it cross the x-axis? 0 times. All right, so there will be questions like this where, like, does it cross once? Does it cross the x-axis once? Does it cross twice? Or does it not cross at all, right? What if I asked you for the y-intercept? Where does it cross the y-axis? 2. I mean, technically the original standard form, so yeah, the c value is 2. Or you could easily think about it, well, my vertex is the lowest point and it's crossing the y-axis at 2, right? What's the range of this guy? Y is greater than or equal to 2. What is the max or min value? Minimum value, because you're going down, 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 reaches the lowest minimum point, and then it goes back up, and that lowest minimum point is the y value of 2, right? Anyway, let's try this one. I want to pause it right here. I want you guys to find the vertex. Go for it. Just to get you started, a little push right here, or shove. You want to start by thinking, I need 3 things to write it in vertex form. I need an A, I need an H, I need a K. And of course, the A value is simple. That's 2. We already got 1 of the 3 things that we need. But the H and K, we're going to find the vertex, because that will technically be our H value and our K value, which the vertex is really an X and Y value. And how do you find that vertex? You use the formula X equals negative B over 2 times A. And of course, we use parentheses when plugging in the B and the A values. And I'm going to stop right there. I'm going to pause. You guys work it out. Let me know once you get a vertex. So here is my work. So far, I've found the X value. I plugged in my B value of 12 over 2 times A value of 2. That's negative 12 over 4. That's negative 3. That is my X value, my vertex. You plug in negative 3 into the original with parentheses in place of X's. And when you do your math, negative 3 squared is 9. Bring down the 2. You have 2 times 9. That is 18. And over here, you have a positive 12 times a negative 3. That'll be a negative 36. And then bring down the plus 18 as well. And when you go from left to right, 18 minus 36, that's negative 18. Negative 18 plus 18, that is 0. I know that feels kind of weird, but the bottom line is your Y value equals 0. And that is your Y value of your vertex. So 0 is right there. Our K value is 0, right? The H is negative 3, K is 0. Now that we know our A, our H, and our K, we could plug it all into the vertex form. Y equals, the A value is 2. Open up the parentheses, X minus your H value being negative 3, close parentheses, squared, plus K, which is plus 0. So this right here is our vertex form. This is what they want from us to find the vertex form. Sorry about that, got kind of sloppy. But here's our vertex form. Let's clean it up. Anytime you have a minus minus, change it to plus plus. What do we have? We have Y equals 2 parentheses X plus 3 squared plus 0, which the plus 0 is not really necessary. If you want to put it, go ahead. You don't have to put it though. This is your nicest looking vertex form equation. So we did what they asked for. We took that standard form and we changed it to vertex form. Let me ask you this. How many times will this parabola cross the x-axis? Once, twice, or not at all? What are the transformations? Does it get reflected over the x-axis? Actually, let's work with the one we got. Does it get reflected? No, it doesn't. It gets vertically stretched by 2, so it's still opening up, but it's kind of narrow. And then what happens? You shift it where? 3 to the left, right? And that means that you're still on the x-axis. So your parabola has the vertex negative 3, 0. That means that it touches. If you want, go ahead and make a sketch right here. 1, 2, 3. It's right here. There's your vertex. It's a little bit narrow, but there's your parabola. It touches the x-axis only one time. Make sense? What else could I ask you? What's the axis of symmetry equation? X equals -3. All right, what else could I ask you? What's the range? Greater than or equal to that minimum value 0. Well, I could have also asked you, what's the minimum value? You would say minimum value is 0, right? What else could I ask you? What's the y-intercept? Where will this pretty narrow parabola cross the y-axis? It's pretty narrow, so it's going to cross way up here somewhere, but visually you can't do it, but algebraically, 18, the c value. Of course, on standard form, y-intercept's great. Down here, you don't even have a number out here, it's a 0, but we know that that's not the y-intercept. You would actually have to set x equal to 0 and solve. 0 plus 3 is 3, 3 squared is 9, 9 times 2 is that same y-intercept value, 18. All right, I think we are ready. On the back side of this page of notes, we have practice. But you know that homework, the practice, yeah, even though I post all the solutions, which, by the way, I think I made a mistake on the axis of symmetry on one of those. The answers are posted, but the homework is just practice. You're not turning it in. It doesn't count towards your homework grade. But there is something that counts towards your homework grade each week, the practice quiz, right? The practice quiz. And there is a practice quiz already available to you. So it's up to you if you want to work on some of the questions on the back side of this worksheet, or if you want to just jump to the practice quiz. The practice quiz does go into your homework grade as 100 points, and you could take it as many times as you want to get the best grade possible. And like I've been trying to maintain, after each question, whenever you submit an answer, there's a video explanation explaining that math question. I appreciate it if you guys let me know when you find mistakes. That helps me out to fix it. So anyways, you have the rest of class to get ready, either by doing some of the homework on the back, or you want to do a couple on the back and then try the practice quiz, or you could start the practice quiz, or you could wait till later to do the practice quiz and just work on the practice questions on the back side of this worksheet.